Two players A and B alternatively toss a fair coin starting with A. If there is a heads followed by a tails, that is the sequence HT, head tails, the game ends and the person who tossed the tails wins. What's the probability that A wins the game? Let's start with a simpler problem of just one coin toss. A and B toss the coin. If it comes up tails, the person who tossed the coin wins the game. If it doesn't, the other person tosses the coin and so on. So A wins if it comes up tails, and if it comes up heads, the game restarts. That is, then B tosses, and then again A tosses. So in a way, if it comes up head, the game restarts with A as the second player. So initially A is the first player and B is the second player. The probability of win of the first player is PA, and the probability of win of the second player is PB. Now since the game continues till one of the players wins the game, so we have probability of A plus probability of B is equal to 1. And from total probability theorem we can write probability of A winning is equal to probability of A winning given that A tossed tails multiplied by probability of tails, that is 1 by 2, plus probability that A wins given that A tossed heads multiplied by probability of heads, that is 1 by 2. Probability of A winning given A tossed tails would be 1, that is A will win the game if he tosses heads. So the first expression becomes 1 by 2 times 1 plus 1 by 2 times probability of A winning given that A tossed heads. So we have the expression probability that A wins the game is 1 by 2 plus 1 by 2 times probability of A winning given that A tosses heads. Now when A tosses heads, we have just seen the game restarts with A as the second player. That is, B tosses and then A tosses back again. And we have also seen that the second player's probability of winning was PB. So probability of A winning given that A tossed heads is the probability that the second player wins is equal to the probability PB. So we have just seen that second player's probability of winning was PB. So, and we have seen that probability of A winning given A tossed heads is equal to the probability of second player winning is equal to PB, which we can write as 1 minus PA. So finally our equation becomes PA equals 1 by 2 plus 1 by 2 times 1 minus PA, and this gives us the answer of probability of A winning is equal to 2 by 3. Now coming to our original problem, we have A is the first player, B is the second player. Probability of win of first player is PA, probability of win of second player PB, and PB equals 1 minus PA. Probability of A winning given that he tossed a heads is denoted by PA given hedge. Probability of A winning given tossed a tails is denoted by this PA given T. From total probability theorem we can write probability of A winning as probability of A winning the game given that he tossed a heads into probability of tossing heads, which is 1 by 2, plus probability of A winning the game given that A tossed tails into probability of tossing tails, which is 1 by 2. So now we have to determine probability of A winning given he tossed a heads and probability of A winning the game given he tossed tails. Now the winning sequence in this question is head and then tails. So if A first tosses a tails, then the game repeats itself with A as the second player. And as we have just seen, the probability of win of the second player is PB. So probability of A given tails becomes equal to PB, and we can write PB as 1 minus PA. So probability of A given tails is equal to 1 minus PA. Putting this into the equation, we get probability of A winning the game equals probability of A winning given A tossed and heads, which we are yet to estimate, times 1 by 2 plus 1 minus probability that A wins the game times 1 by 2. So now we look at this part, probability of A winning given A tosses heads. Now when A tosses heads, A's probability of winning is probability of A given H. So B's probability of winning would be 1 minus probability of A winning given A tossed and heads. Or in the other words, when the first player throws a heads, the subsequent player's probability of winning is 1 minus PA given H. Now, when A tossed heads and it's B's turn, if B tosses tails, B wins the game. So in that case, A's probability of winning is 0. So if B tosses tails, which will happen with probability 1 by 2, A's probability of winning is 0. So 1 by 2 times 0, plus if B tosses heads, which will happen with probability 1 by 2, A's probability of winning is PA given B tosses heads. Now, as we've just seen, after a player tosses heads, the subsequent player's probability of winning is 1 minus PA given H. So probability of A's winning given that B just tossed a heads is 1 minus PAH. So we substitute this back into this equation to get probability of A winning given that A tossed heads is 1 by 2 times 0. This is when B tossed tails and won the game, plus 1 by 2 times 1 minus PA given H, that is when B tossed heads. The A's probability of winning is 1 minus PAH. So solving this, we get probability of A winning given that A tossed heads is 1 by 3. Now plugging these values into the original equation, we get an equation in terms of PA, which is probability of A winning the game, and we can solve this to find the final answer, which is probability of A winning equals 4 by 9. Now this question can also be solved in a much simpler and easier way using Markov chains, and drop in the comments below how you would solve this using Markov chains. Thanks for watching.